Okay, we're in example, we're doing example section 15 of the notes. We'll go through each example separately. I may not do every single piece of work in the notes, sometimes it gets a little bit long and tedious. However, I do want to encourage any students that need additional support, come by during office hours, and I'll be more than happy to help you. There's also some embedded videos. They may or may not be helpful, depending on who the student is. All right. So let me go to the whiteboard and we'll start doing the examples. A little long section on examples, but a lot of it just to review what you've done in Math 120. So just give me 1 second to do a share with you. And okay, you're seeing my whiteboard. And again, when I'm doing the questions over here, I hope you understand what the questions are. And what they want to do is, write the first 6 terms down. And this is going to be where AN is defined a certain way. And they say, well, let's write this down. Let's say list the first 6 terms starting with n equals 1. Let's put down n equals 1. So that means A1, right? So it's going to be cosine of pi, because then it's 1, right? Plus, well, that's going to be 1. And what goes on bottom would be 3 plus 2, which is 5. Cosine of pi is -1. -1 plus 1 is 0, so 0/5. So that's 0. First term done. Let's do A2 now. A2. And again, I realize some students get, do I need to write that down? I don't know. I do. And it's going to be 3 plus 4, right? Whoops. Well, the bottom's super simple to do. It's 7. Cosine of 2 pi is 1, and 1 plus 4 is 5. Bingo. All right. Let's put down A3 now. So A3, that's going to be, oh, they're getting more difficult now, right? So 3 is going to be 3 pi. So just think about it. 1, 2, 3. That's -1, isn't it? Plus 9. And that's going to be 3 plus 6, which is 9. So 8/9. Well, got that one right too. Let's put down A4. Well, it's going to be 1 plus 16. I'm getting a little better now, aren't I? So it's going to be 3 plus 8, 11. That's 17/11 now. Bingo. Let's do A5. Yes, I know it's tedious. So let's see what we got over here. It's going to be -1 now, plus 25. And on bottom, you can get 3 plus 10, which is 13. So 24/13. Let's do A6. That's going to be 1 plus 36. Fairly simple, because I'm getting a knack of it. And 3 plus, that's 12, right? So 15, 37/15. Bingo, got it. Okay, now they're asking me to find the general term of this one over here. And it's always an issue about how to do that. But I'll be honest with you, I'm looking at one guy, and he just doesn't look like he belongs. All right. So I'm going to outline that guy, that this guy here really looks strange to me. So I'm going to dress him up, and I'm going to dress him up so he looks like he fits in. So every single top should be a 7, right? So I'm going to say this guy really should be 7/14, which same thing as 1/2. So I'm going to say now AN. I'm going to be starting at n equals 1. Every single top's 7 now. What's the bottom? We'll look at it. 2 to 5. That goes up by 3. 5 to 8 goes up by 3. 3 to 11 goes up by 3. Now 11 to 14, I'm not saying 2, goes up by 3. And 14 to 17 goes up by 3. So it's something to do with 3n. It's something to do with 3n. But I notice the first term is 2, so I'm going to say 3n minus 1. Now, does that work? Well, if I chose 1, I'd get 3 minus 1, which is 2. If I choose 2, I'd get 6 minus 1, which is 5. 3 would be 9 minus 1, which is 8, so forth and so on. So this is it. Starting at 1, AN is equal to 7/3n minus 1. Got it. All right. Now this one over here, it says list the first 6 terms starting with n equals 1. Gee, they gave that to me. They gave me A2 too. I can't complain about that. I got the first 2 correct. Gee, what's A3 then? A3, I'm looking at the formula, is going to be A2 plus A1 over 2. Do you know what A2 is? Yeah, it's 1 plus 0 over 2, and that's 1/2. All right, let's put down A4 now. Again, I'm using the formula. It's going to be A3 plus A2 over 2. Do I know A3? Yeah, it's 1/2. It's over here. Do I know A2? Yeah, it's 1 over 2. So that's going to be, let's see, 3/2 over 2, 3/4. All right, let's put down A5. What's A5? A4 plus A3 over 2. Do I know A4? Yep, it's 3/4. Do I know A3? 1/2, right? Over 2. Well, let's see if we can do that. It's a little more difficult. I can multiply top and bottom by 4. I get 8, 3 plus 2, 5/8. All right, let's put down A6 now. What's that going to be? A5 plus A4 over 2. Well, that's going to be, again, a little bit easier now. So it's going to be 5/8 plus 3/4. Hang on, let's put top and bottom by 8. 16 at the bottom. 5 plus 6, which would be 11/16. Let's see how we did. Bingo, not so bad. That's recursive, okay? This one says, give a recursive formula for this one over here. So recursive is defined in terms of itself, and I'm looking at it. I'm not saying it's easy, but it's something that I think most students recognize at this point, something that I think was introduced to you, at least at Essex College, at the Math 120 level. And this is what's known as the Fibonacci sequence, where the seed value, A1, is equal to 0, and A2 is equal to 1. Now, how would I get A3? Well, A3 appears to be the sum of the prior two terms, so it would be A2 plus A1. How about A4? What would that be? Well, that would be the sum of A3 plus A2, so forth and so on. So I'm going to write down my recursive sequence now. What's going to be? AN is going to be the sum of the two prior terms. So A, n minus 1 plus A, n minus 2. I got to give the two seed values. So I'm going to say A1 is 0 and A2 is 1. That's enough to define that sequence. Let's look what we've done over here. And they said AN is equal to AN minus 1, AN minus 2. Yeah, they say N is greater than 2. It should be. The reason for that is I'm starting at A1. So they say A1 is 0 and A2 is 1. All right, that's good. That's the next one. Oh, wow. Show the nth partial sum of the geometric series is this one over here. Well, let's write it down. Right, let's write Sn down. There's many ways to do this. Do not think the way I show you is the only way to do this. All right, so they gave me that. They said it's a formula, so let's see what they do. What I would do is I would multiply both the left and right of the equation by the common ratio, which is x in this problem over here. This is something you learn to do in Math 120, by the way. I'm not saying you remember everything from Math 120, but if I multiply the left by x, I multiply the right by x, every term is being multiplied by x. So I get ax. I point out what I did over here. I multiplied this term by x. Now, if I multiply this term by x, what would I get? I would get ax squared. This would keep going. Then I'd get to this over here, a to the x to the n plus a to the x n plus 1. So repeat what I did over here. I took every single term and I multiplied it by x. I would get ax squared, ax cubed, all the way up to a to the x to the n plus 1. So I just wrote that down over here. By the way, I'm going to erase that because it doesn't look like an n plus 1 to me. So just give me one moment. I'm going to make it much more clear. That's n plus 1. Then what do? They subtract. All right. So how would they subtract? The easiest way possible. So I'm going to write down Sn minus x Sn is equal. Well, what's nice about the subtraction is a tremendous number of terms will disappear. And what are you left off with? Well, you're left off with a minus a x to the n plus 1. I'm going to keep moving forward. On the left, I'm going to factor out Sn, and you would get 1 minus x. And on the right, I'd factor out a, and you would get 1 minus x to the n plus 1. Then I'm going to divide both sides by 1 minus x, and I get this. Now, by the way, I'm not claiming it's their formula. I'm just going to look. Did they get that formula? Or could I rewrite my formula to look like their formula? I don't know. I have to look at their formula. And what's their formula? Exactly what we said it was going to be. All right, that's good news. All right, no need to memorize. You should start to understand things though. And hopefully this is jogging your memory from what you did in math 120. All right, I'm going to next page. And a little work over there. Oh boy, this is a tough one. It says, suppose you're offered a 35-hour job that pays a penny in the first hour. All right, I got to write this down. So I'm going to say the very first hour, I'll call it A1. They gave me a penny. I'm just going to write down a penny like that. I'm not going to write down 0.01 because it's too tough for me to do. I deal with pennies anyway. Well, the second hour, what do they pay me? They double it. They pay me 2 pennies. In the third hour, what do they pay me? Well, I double it, right? That'll be 4 cents, right? A lot of people just give up. I'm not going to give up. I'm going to keep doing this. By the way, there's a point to this. A lot of people give up. They say the payout's too little. Why would I even do that job? Like you can give me a penny for the first hour and then 2 cents and then 4 cents. I'm not going to take that job. And then you're only going to make me work for 35 hours. That's crazy. I'm not going to go there. What's A4? That's going to be 8. Right? And then I'm really tired. So, well, how long am I going to work? 35 hours, right? Well, it's where a lot of students really bog down and say, I don't know what the hell that would be. Well, let's take a look at that. This is 1. This is actually the first guy multiplied by 2. This is the last guy multiplied by 2, so it's going to be 1, 2 squared, right? And this is going to be 1 times 2 cubed. Again, I'm hoping that's not too difficult to think about. We would love for you to think about it, though. So 1 gives me no 2s. 2 gives me 1 2. 3 gives me 2 2s. 4 gives me 3. Gee, how many would 35 give me? 35 would give me, let me see what that would give you. It would be 1. Whoops, I didn't mean to put that down like that. 1, did it again. 1 times 2 to the 34th. All right. I don't mind you using a calculator, but I don't think that's a good idea to write the number down now. All right, I want to do the sum. So let me read that in. Suppose you're offered a 35-hour job that pays a penny for the first hour, 2 cents for the second, 4 cents for the third, and so on. So on means you get the pattern. It's being doubled. Each hour you work, your earnings are twice your earnings in the previous hour. Exactly how much money would you have earned if you worked all 35 hours? All right, so I got to write that down now. So that's a sum. So I write the sum down for you. And what's the sum? 1 plus 2 plus 2 squared plus 2 cubed plus yada, 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 up to 2 to the 34th. Well, prior knowledge works a good deal on us, and certainly I'm just going to, multiply both sides by 2. So 2s. And what would you get? 2 squared, 2 cubed, plus yada, 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 up to 234, and then you get 235. Then repeat what I just did over there. I multiplied the left by 2, you multiply every term in the right by 2. So you get 2 squared, 2 cubed, 2, 4, up to 235. That's all I wrote down over here. Then what I'm going to do, probably subtract. All right, probably subtract. Let me write that down for you. So I'm going to write down 2s minus s. All right, now what's that going to be? That's going to be 2 to the 35th minus 1. All right, what does this give us? S would be 2 to the 35th minus 1. And by the way, I don't mind the answer, but certainly if you said, oh, your paycheck's going to be 2 to the 35th minus 1, you wrote that in a check, the check would bounce, would go back to you saying that's just absolutely crazy. How could someone even speak like that? So what I want to do is I want to briefly share another screen with you. And I'm going to do a new share. And give me a moment to do so. And I think we are on this problem over here. And I want to see if I can, take my chicken scratch. And I'm going to go to Sage. And someone says, why do you use Sage? We're trying to encourage you to use Sage. All right. In the past, we were using a program called Mathematica. And Mathematica is a great application, very expensive. The school stopped paying for it because I was the only one at the school using it. And they said that was ridiculous. If the students weren't going to use it, why would they pay that kind of money for just Ron Bannon to use it? But I'm going to type this in for you. And what is it? It's 2 to the 35th, right? Minus 1. And that's that number over there. But again, what I'm going to claim over here is I really didn't want that number. I wanted the money number. So what do you have to do? Divide that by 100. So I'm actually going to look at my whiteboard now. I'll go back to it in a second, but I have to write that down. I can't remember that number. So I'm going to write down S in dollars is going to be 343,597,383.67. I'll put a box on that. And again, it's a money problem. So I'll put some nice little parentheses in over there. And that looks like a really large number to me. I want to see if I get the same number over there, which is 343,597,383.67. That's $343 million. That's a lot of money, right? So what's the take-home tale on that one over there? Keep at it. All right, keep at it. Let me go back to my whiteboard now. And give me a second to do so. And where are we? Oh, does the series converge? I'm sorry, I misspoke. Does a sequence converge or diverge? Well, I guess this really couldn't be any easier because all we're going to do is, does the limit as n goes to infinity return a finite number? I don't know. Let's put this down. So I got to write down the limit as n goes to infinity. By the way, I should have pointed out that, let me see where I was. I'm sorry about that. That I did write down the number and I did check it against my notes for that last problem. I'm sorry, I should have mentioned that. I did write it down. I did verify it. And someone says, you didn't do the calculation. Calculator did it. You're right about that. If this were an exam question, though, I'd write down S is equal to this. That's right down. Let me repeat this. If you were ever to write that down on a check, they would send the check back to you with a fine. All right, you get a fine for writing something like that down. Don't write things like that down. That's crazy. Now, mathematics will accept it as the right answer because it's equivalent to this one over here. But in the real world, that would be crazy. All right, absolutely crazy to write that down. Let me go whoops, sorry, I didn't mean to do that. Let me go back to that problem I was talking about, this one over here. So limit as n goes to infinity of this guy over here, and write a little bit differently. It's going to be 1 minus 1 over e to the n and 1 plus e to the n. And this limit is pretty easy because the top limit, if you think about it, the bottom would be, I'm sorry, when I talk about that, I'm talking about the top now. This guy over here is going to be 1 minus none, which is 1. And the bottom goes towards infinity. And 1 divided by infinity is 0. So yeah, finite number. It converges. We say 0. All right, this one a little more difficult. A lot of students get confused by this one over here. But the limit as n goes to infinity of minus 1 to the n. Well, the problem with this thing is you go to infinity, it bounces back and forth between plus or minus 1. So it's a D and A. So the answer there is it diverges. All right, let's go to the next page. I'll have that answer down for you. So D and A sequence diverges. This one a little more challenging. I'm going to put it down for you. Limit as n goes to infinity This is my own issue. It may not be your issue, but I'm going to put down -7 tenths. It's the same thing as -0.7 to the n. What about this one over here? It's a proper fraction and it's going to shrink to 0. All right. So it converges. All right. Limit 0 converges. Let's do this one over here. Get a limit problem. Limit as n goes to infinity. And you get 1 plus -1 to the n. Well, if I thought about it, you go towards infinity, it could be 1 plus 1, or it could be 1 minus 1. So it bounces back and forth between 2 and 0. So it's a D and E. Just bouncing around. All right. So what do I say? Diverge. D and E diverges. All right, let's do this one over here. A limit problem. I'm thinking. N goes to infinity. 1 plus -1 to the n over n. This one requires a little bit more thought, by the way. The top bounces around. It could be 0, could be 2, could be 0, could be 2. The bottom going to infinity though. So if the top is either 1, I'm sorry, 0 or 2, but the bottom is going towards infinity, this will go towards 0. All right. So what do I know about this thing? It converges and the limit's 0. All right, let's go to 12. What's the next page? Well, I hope all questions are like this. Limit as n goes to infinity. This is of a sequence. And this is going to be 2n minus 3, 3n plus 4. Well, if we divide by the highest degree variable, which is n, you get 2 minus 3 over n. The bottom would be 3 plus 4 over n. And the limit would be 2/3. So the limit's 2/3. You know what? They didn't ask me to do that. They didn't ask me to do that. What was I thinking? I was thinking it was the same question that 11 was. That wasn't their question. What was their question? Let's go back and read it now. And this is a problem a lot of students do. They don't read. They think that it's the same question that they saw before. It could be. I'm not saying it's not. But they said determine if the sequence is increasing, decreasing, or not monotonic. Well, I'm looking at it, and I got a suspicion about this thing, and that it's decreasing. I'm looking at it, and I'm going to say I really believe that this thing is decreasing. So if it's decreasing, what am I going to say? I'm going to say that if it's decreasing, AN, did I say decreasing? Let me think about that. Maybe I misspoke. AN, I'm going to say +1. Let me think about that. I don't know. I'm going to say I don't know the relationship between the two, but I want to write them down for you. This is going to be 2n minus 3, and this will be 3n plus 4. Let me write the next one down. It's n plus 1, what you get? You get 2n plus 2 minus 3, which is -1. What do you get on bottom? 3n plus 3 plus 4 is +7. All right. So I'm going to put like a question mark between these guys over here. I have no idea at this point. Right. I know the limit's 0, but I wonder, how's it doing that? And there are many ways to do it, but let's take a look at it. I'm going to say these are all, let's see, for some n, I'm going to say for n's greater than or equal to 2, they're all positive terms. So I have a much easier dealing with the inequality now. So it's going to be 2n minus 3. We're going to fill in that question mark later. 3n plus 7. This question mark is going to hold for that n, by the way. And then you can get 2n minus 1, 3n plus 4. I'm going to multiply them out. Again, the question, I'm wondering what that question is. Is it greater, less than, equal? Who knows? Let's see. We have 6n squared plus 14n minus 9n minus 21. Put this in again. This is going to be 6n squared. 8n, oh boy, let's see, minus 3n minus 4. Let's keep writing it. So 6n squared plus 5n minus 21, 6n squared plus 5n minus 4. I think you get an idea here, right? Let's see if I did that right. 6n squared, 14n minus 9n, 5n minus 21. 6n squared, 8n minus 3n is 5n. Yeah, I'm going to subtract 6n squared from both sides. Well, that disappears. Subtract away this from both sides. That disappears. And what are you left off with? Well, let's write this down. Minus 21, question, minus 4. At this point in the game, I'm really kind of convinced something's happening here, right? What number is greater? Minus 4 is. So I'm going to put that down now. So I'm going to get my eraser out, and I'm going to start filling that in for you. So what am I saying? I'm saying an plus 1, the term above the an, is bigger. So what is it doing? Increasing. All right, that's one way to do it. I'm going to show you another way of doing it. And the other way of doing is thinking about what you've done in Calc 1. I'm going to write that down for you now. So what I'm going to do is I'm going to do f of x. I want to go back to Calc 1. This is 2x minus 3. And this would be 3x plus 4. F prime. Yeah, it's work too. I'm using a derivative. And derivatives are used to determine if functions are increasing and decreasing and where they're doing that. All right, what do you get over here? Well, 2x minus 3. Tell you where the bottom, which is 3. I got more work to do. So it's 3x plus 4 squared. What do you get on top? We get 6x minus 6x. There's no x's. 8 minus, or that's going to be plus, right? Let me write that down. So the x's disappear. Again, 6x minus 6x is nothing. 8, it's 17, right? What do I know about this guy over here? It's going to be positive on it. Positive. It's increasing on its domain. This is increasing on its domain. All right. Now, someone said, what domain of this guy over here? It's just the integers, and this is going to be the integers starting at 1 forward because we're starting at 1. So what I do, I said it's always positive, so it's increasing, and just like we did over here. So you get one of two ways of doing it: going back to calculus, or just simply looking at it and showing something or the other. All right, let's do this one over here. A little more challenging. It's got the e in it, so I'll write this one over here. That's really the same old nonsense I put down. So it's an n e to the n. And then I say, I wonder how an is related to an plus 1. I don't know. Let's write it down. N over e to the n. And this would be n plus 1 over e to the n plus 1. Right? I'll put a question mark between it. Now, what do I know about this is for integers like 1, 2, 3. Certainly both sides are positive. So this can be a really simple inequality to deal with. Nothing as difficult as you've done in Math 119. Boy, looks like it's going to be tough, right? Let's put this down. N e to the n plus 1. This should be n e to the n plus e to the n. I'm going to divide both sides by e to the n. Makes it easier for me. N e. I'm dividing by e to the n, by the way. 1. I'm sorry, not 1. It's n. Sorry, n plus 1. Right? It doesn't look too easy, does it? I'll write this over here. So n e question n plus 1. All right, so NE is n times E greater than n plus 1. Let me write this down. Factor an n out, and I would get E minus 1. Well, I hope you realize that E minus 1 is bigger than 1. Would that be agreed? E minus 1 is bigger than 1, and n is going to be 1 or bigger. So this is clearly bigger. So I'm going to write that down now, get my eraser out. Let me get the eraser for you. Erase all these guys over here. Whoops, real eraser out here. I'm going to go back up here, erase these two. Whoops. Why can't I erase that? Maybe because it's the past? Too much in the past? So let's write this down now. So bingo, 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 bingo. I'm just going to cross these out now. Bingo. Cross this out. Bingo. So what am I saying? Well, it's decreasing. Okay. So I'm going to talk about the calculus way of doing this. I'll write this over here. F of x equals x over e to the x. I'm going to do this over here. That's going to be e to the x squared, e to the x times 1 minus the top times e to the x. And when you get over here, factor out e to the x, you would get 1 minus x over e to the x squared. I'm going to continue to simplify it. And you're going to get 1 minus x over e to the x. And I hope you realize the bottom is always positive. And then if you look at the top, I want to point this out to you. There is a critical number. It's 1. And, certainly if I look at 1, I'm wondering what happens after 1. Well, you plug a number in, it's going to be a negative number here on out. Sign analysis, so it's decreasing. Just like we concluded over here, decreasing. All right, let's look at number 14. And, certainly I'm reading it's the same old question again and again and again. And I'm going to write this one down. I may get suspicions about it, increasing, decreasing. Oh boy, let's take a look at this over here. N, AN. How's it related to AN plus 1? Well, let's write down. I don't know. So let's read. It's going to be N plus 1 over N. I don't know. N plus 1 over N plus 1. Well, I think I can subtract N from both sides, right? So I get 1 over N. And then you get 1 plus 1 over N plus 1. Right? You get the idea what I'm doing, at least I hope, right? 1 over N. This would be N plus 1. Then get N plus 2 over here, right? Well, I'm going to say for N, we're not dealing with negative N, so this is a really easy inequality to solve. And you're going to get, let's see, you'd get N plus 1. Then you get N plus 2. This would be N plus 1. And it's a lot of work. N squared plus 2N. I'll put a question mark over here. N squared plus N minus 1. This would be 0. And I hope you realize here, looking at it, right? Looking at it, if I chose N to be 1, it's positive. If I chose N to be 2, it's positive. And that's always going to be greater than 0, by the way. So what do I know about this? I get my eraser out. It's work too, right? Get my eraser out, try to erase all this nonsense over here. And this is always going to be like this. What is that indicating to me? Increasing. All right, let's take a look at the calculus. The calculus, yeah. What I mean by the continuous calculus. F of x equals x plus x to the minus 1. F prime of x is equal to 1 minus x. I'm sorry, I shouldn't do that. Yeah, I'll do that. Minus 2, which is going to be x squared minus 1 over x squared. And then I do my sign analysis on its domain. Domain is going to be above the 0, by the way. What I mean by that, the domain of this thing is n equals 1 forward. So I have to be above the 0. So my analysis is going to start at 1, but because it's a critical number. And what do you get after 1? Plugging it in, like, plug in 2 or so. And what number would you get? Positives, increasing. Okay, not bad. You got an increasing sequence there. All right, so let's take a look at the next one. I think I'm getting a little better now, right? After all that practice, kind of looking at it. And I'll write this one down. So I'm going to write an and an plus 1. I'll write an down as n squared plus 1. And this would be n plus 1. On top, on bottom, you get n plus 1 squared. I'll simplify that in a second, and I will erase it because I think many can do this in their head. This would be n squared plus 2n plus 1 plus 1. So I'm going to erase it now. All right, I'm going to put that down for you. That'll be n squared plus 2n plus 2. All right, so let me get the eraser out. Erase this business over here. I'm not going to put the question mark over there, by the way. We'll do it later. So what do you get over here? N, whoops, n cubed plus 2n squared plus 2n. And over here you'd get, I'm multiplying n cubed. Again, what I'm doing over here, I want to point out to you we're kind of multiplying both sides by the LCD, or what some students call cross multiplication. All right, we'll put the symbol in later. So that's going to be n cubed plus n squared plus n plus 1. And I'm going to start canceling things from both sides, like I'm subtracting them away. So let's see what we get. I got that canceled off, and I'll take n squared from both sides, so you get n squared. I'll take n from both sides. I'll say that's n. And I get a 1 over there. I hope you realize that the domain of this thing over here is, n starts at 1 and it keeps going on and on. Positive numbers makes this inequality so easy to deal with. I'm going to say clear as day that this is true. What does that mean? It's decreasing. That the next term is smaller than this one over here, decreasing. All right, let's do this one over here. And we're back to that limit again. All right, so limit, let's write it down. And this is called dn, so limit. This is going to be tough, by the way. N goes to infinity. Well, I can put the minus on the outside. 8/9 to the minus n. I don't like the minus n, to be honest with you. It's going to be minus limit n goes to infinity 9/8 to the n. All right, so I'm looking at that. And I'm wondering, can I do that limit if n gets really large? Well, the top grows much faster than the bottom at some point. So what's this going to be? Minus infinity. So what do I know about this? It diverges. All right. Minus infinity diverges. Let's do this one over here. And the same thing, limit n goes to infinity. I'm going to divide by the highest degree variable. And don't worry, you don't need to write this down, but I'll write it down for you. 4 over n squared plus 1 over n minus 7. What do you get on bottom? 9 plus 3 over n squared. Well, this limit is actually easier for me to do. And what do I get? I get minus 7 on top when n goes to infinity. And on bottom, I get 9. So this is a finite number. It converges. So 17, the limits minus 7/9, and the series converge because it's a finite number. All right, let's look at number 18. And, I'm not saying you have to do a lot of work for these things, but let me write this down for you. The limit as n goes to infinity, that's going to be 11 to the minus 1 over n. And let me think about it. So if n goes to infinity, what would you get? The minus 1 over an infinity is going to be 0. And 11 to the 0 is 1. Well, that's not so bad. So what do I know about that? That it's convergent. all right? Converges, limits 1. All right, same story. They're going back and forth now. Let's take a look at this. Limit n goes to infinity with the natural log. Well, I hope you realize as you go to infinity, the natural log, that the inside argument is going to be positive, so this is fine. So I'm just going to do a limit at the inside. What do you get? Natural log. I'll divide by the highest degree variable, so it'd be 7/4. It converges. It converges to that number there. All right, 20, I don't know. Factorials are always a nightmare. And, writing down a limit or going to calculus just not going to help me. So I got to write down Vn for you. And, I'm going to talk about what the bottom looks like. And the bottom is a factorial. So it's 1 times 2 times 3 times 4 times yada, 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 all the way up to n. I'll get my eraser. I went too far on that one, didn't I? Then someone says there's something on top too. And it's true, there is something on top. It's 11, and it's going to be n factors in them. So 1 would be with the 1, 1 would be with the 2, 1 would be with the 3, 1 would be with the 4, and then there's 1 for everyone else up to that one. All right, so I'm going to write that a little differently for you. 11 over 1, 11 over 2, 11 over 3. I'm already getting tired. Yada, yada, yada. We'd eventually get to 11 over 11. What's the one after that? 11 over 12. Sorry. 11 over 13. 11 over 14. I'm getting tired again. All the way up to 11 over n. Well, I got to look at this over here. And so why do you look at this? Well, I'm looking at this thing over here, and I'm going to say, I know that's a number, right? It may be an outrageously difficult number to compute, but I know it's a number. And then I'm going to look at these things. And what do I know about these things over here? They're increasingly, really increasingly getting smaller and smaller. Eventually, this is going to be 0. That bottom gets so large so quick, it's incredible. So what am I going to say? Limit, thinking about it, as n goes to infinity of Vn. I'm thinking about it. The bottom grows much faster than the top, much faster. So what do you get? 0. It's convergent, and it converges to 0. All right. So I got that written over there. By the way, I'm using the squeeze theorem. No, you don't need to do that. But I'm going to notice I'm using the squeeze theorem. So it's the limit's 0. Let's go back to the next page, see if they said that. Sequence converges, limit 0. Let's do this one over here. Yeah, a little more challenging each time. At least I think they are. By the way, I don't like the fact that they use e to the n, but that's okay. All right, so what do you get over here? This is actually the natural log of n squared plus 6 over n squared minus 1. All right, so I know these are positive n, so everything looks pretty good, at least if we're above 1. Like if you're at 1, you're in danger zone. So I'm going to say n is greater than 1 for this problem over here. All right. I can't put down E1 for you, but I can put down 2, 3, 4. So we're looking at limit as n goes to infinity of the natural log. And as long as I'm above 1, this is going to be nice. What would that give you? Well, they're all positive numbers now on the inside. So it's going to be the natural log. And the limit of the inside is going to be 1. And what's the natural log of 1? 0. So what do I know about this guy over here? This sequence converges to 0. Okay. Let's do the next one. Boy, this looks just like the other problem we did, doesn't it? Just like it. Really is. Just like it. The bottom grows much faster. So I'm going to say, I think I'm pretty comfortable with this. Limit n goes to infinity. Un is 0. All right. Again, same argument we did before, but it's going to be 0. And they use the squeeze theorem again, by the way. Let's do number 23. And I'm gonna write this down for you. Limit n goes to infinity. I'm gonna divide top and bottom by 4 to the n. So it's 3, 4 to the n. Let's see, minus 8. And on bottom, you would get 2, 4 to the n. We're dividing by 4 to the n, plus 9. And what's that limit? That's really simple. It's minus 8/9. So this sequence converges, and it converges number minus 8/9. Next page. Boy, a lot of limits. There is no next page. We're done. All right. Thank you for your attention.